Welcome, everyone, to this explainer. I'm absolutely thrilled to have you here. Today, we're tackling a fascinating topic that plagues, well, almost every growing engineering team: how exactly we organize our code. You can kind of think of software architecture like city planning. When you're just starting out building a single house, super easy. But what happens when that house turns into a sprawling metropolis? Suddenly, you have to worry about the plumbing, the traffic, and making sure the entire infrastructure doesn't just collapse under its own weight. That right there is the universal pain of scaling an interconnected codebase.
Okay, let's dive right into this structural roadmap. First, we'll look at architecture, monorepos versus polyrepos. Then, the monorepo scaling wall. After that, branching and release strategies, followed by optimizing with selective builds. And finally, choosing your architecture.
So, Part 1. Architecture. Monorepos versus polyrepos.
First up, the monorepo. By definition, a monorepo is a single, centralized repository housing all the code for multiple, often highly diverse projects and services. Imagine a massive, interconnected city where everyone shares the exact same infrastructure, the same roads, the same plumbing. If you update a core utility, every single building in the city gets the upgrade immediately. It acts as a single, centralized source of truth for your entire organization.
Now let's compare that directly to a polyrepo approach. Monorepos give you atomic commits, unified tooling, and seamless application-wide refactoring. I mean, you can update an internal API and refactor all of its consumers in a single pull request. But polyrepos, they offer granular isolation, independent lifecycles, and very clear boundaries. If a monorepo is that massive shared city we just talked about, polyrepos are more like independent, gated suburbs. They govern themselves, they move at their own pace, and they definitely don't share plumbing. Which means a broken pipe in one suburb doesn't flood the other, sure, but it also means upgrading the whole region takes a heck of a lot more coordination.
Moving on to Part 2, the monorepo scaling wall.
Now, what's really interesting here is that while the monorepo city sounds great in theory, the reality of growth brings some serious growing pains. So what actually happens when the monorepo scales? Imagine your perfectly planned, interconnected city suddenly experiences a massive population boom. It becomes way too crowded, traffic just grinds to a complete halt. In a monorepo, this translates to sluggish operations. You change one single line of code and suddenly your CI pipeline decides it needs to test every single project in the entire repository. We call this the dreaded build the world problem.
This quote from the source material really validates that developer pain. It states, version control operations suffer severe performance degradation, sometimes requiring gigabytes of data transfer. Let's be honest, there are few modern horrors quite like waiting 45 minutes for a CI build to pass, or having to download literal gigabytes of data just to run a simple git status query to fix a typo. The friction becomes palpable.
But hey, don't abandon hope just yet. Check out this number: billions. Tech giants like Google store billions of lines of code in a single massive repository. It proves that incredible, unprecedented scale is entirely possible. But you can't just dump billions of lines of code into a standard Git setup and expect it to work seamlessly. It requires incredibly specific management strategies.
Which brings us to Part 3, branching and release strategies.
To fix our congested codebase, we need serious traffic control. The foundation of this is trunk-based development. This strategy relies on small, frequent changes merged directly into a central, always deployable branch, usually called main or trunk. In a large monorepo, traditional long-lived branches are an absolute nightmare because they freeze unrelated projects and create these massive, complex merge conflicts. Trunk-based development forces you to integrate continuously, avoiding that chaos entirely.
And this brilliantly illustrates how companies like Meta handle the branching problem without breaking the monorepo, using their sapling workflow. Since traditional full repo branching doesn't scale, Meta developed directory branching. Here's how it works. Developers copy code to a specific directory, cherry-pick their changes, and, crucially, those directory branches project as perfectly linear commits back onto the main graph. It preserves Git-like speed for historical logging without freezing the rest of the repository. It's just an incredibly smart workaround.
Okay, so once the code is merged, how do we actually release it? We've got a direct comparison here. Synchronized releases slap a unified version tag on the entire monorepo and deploy everything simultaneously. Sure, it guarantees compatibility, but it's that really heavy build-the-world approach. Independent releases, on the other hand, treat each component as an isolated deployable unit. They have their own semantic versioning and path-filtered triggers. It's vastly more modular and honestly much more efficient for agile teams.
To manage those independent releases cleanly, a lot of teams use an interactive CLI tool called change sets. Instead of relying on automated commit parsers that kind of just guess what you want and create incredibly noisy changelogs, change sets forces explicit developer intent. You go through a few simple steps. First, you manually select the affected packages. Second, choose your semantic bump type, major, minor, or patch. And third, write a human-readable summary. It creates a markdown file that is reviewed right alongside your pull request. It brings human intent right back into the automated release process.
Let's move to part 4. Optimizing with selective builds. We've talked about traffic control, now let's talk about the assembly line itself. How do they ensure developers aren't wasting their days waiting for massive pipelines to finish? 7 minutes. This is a genuinely striking anecdote. Stripe managed to cut their CI times from an agonizing 45 minutes down to just 7 minutes after migrating over 300 services into a single monorepo using Bazel. That is a game-changing level of optimization. But how is that kind of speed even possible in a massive code base?
Well, it's possible through these exact optimization mechanics. Think of this like an incredibly intelligent assembly line. When a car comes in with a broken taillight, you don't rebuild the entire engine, right? You use selective builds to only compile the parts of the code base that actually changed. You use content-aware caching, which hashes task inputs to serve up already cached outputs, saving massive amounts of build time. And you use dynamic pipelines that look at the exact git diff at execution time to generate only the specific testing steps required.
So the crucial point here is how these tasks are orchestrated. Enter Distributed Task Execution, or DTE, managed by platforms like NX Cloud. Traditional CI relies on static machines just sitting idle while waiting for sequential tasks. DTE completely fixes this bottleneck. It initializes a main coordinator job that evaluates your project's entire dependency graph. Then, it dynamically passes tasks to a pool of agent jobs based on real-time availability. It even allocates computational resources based on the size of the pull request. It's dynamic, it's incredibly fast, and it ensures literally zero idle time.
Finally, Part 5, Choosing Your Architecture.
Now for the blueprint phase. Let's map out a strategic architectural assessment to see which structural approach is actually right for your specific engineering team. Your choice depends entirely on variables like team size, service coupling, and language diversity. A monorepo is absolute magic for tightly coupled services sharing a tech stack, allowing maximum velocity. But the strict requirement is that you absolutely must invest in platform tooling and dynamic CI caching, or you will hit that scaling wall hard. A polyrepo, on the other hand, is best for geographically decentralized teams that need totally independent lifecycles. But the big trade-off requirement there is that you need incredibly robust contract testing. Otherwise, integration failures will tear your systems apart when those independent services finally try to talk to each other.
The ultimate takeaway from all this architecture strategy comes down to a slightly provocative question. Look at your tech stack right now and ask yourself, is your current architecture actually serving your team, making them faster and more collaborative? Or is your team just serving the architecture, fighting slow builds, messy dependency chains, and disjointed tools? Thank you so much for joining me for this explainer. Definitely use these insights to audit your own setup and keep building.